Good morning, good afternoon, wherever you come to us from. Thank you very much for joining us again on Monday, April 6th. I believe this is our fourth webinar in this mini-series. I hope everyone had a wonderful weekend and had the chance to enjoy the outdoors or enjoy time with their family. Let's get into it. This is the fourth one, as I said, and we're going to dive into the internet layer, the inter-protocol layer, I should say, IP addresses, DHCPs, and so on. Sorry, my bad. My name is Ping. I am CEO of Optical Networks, and Thomas McGee, sales engineer.
Hi, guys.
We're both coming to you from our homes as we are under lockdown here in Vancouver. As in all our other webinars, if you have any questions, please don't hesitate and ask away using the chat box in this GoToWebinar application. Natalie in the back end will field these questions and either answer you directly, push them to us, or wait until the end. But in your for your sake, don't wait. Just ask away. We do want to have as much interaction as we can. At the end of the webinar, please fill out the survey. It helps us understand what is good, what is bad, how can we improve this, what subjects you like to hear, and so on. And as always, this session is being recorded and is available on our YouTube channel. Our next session is tomorrow. Tomorrow at 11:30 Pacific Standard Time morning and 2:30 p.m. Eastern Time. Tomorrow we talk about gateways and firewalls, particularly. So a little bit more cybersecurity tomorrow. Moving forward, I'm just going to disable my my webcam because my internet's been a little glitchy. So to avoid any problems, I don't think you need to see me. Let's continue.
Perfect.
Thomas,
thanks. Yeah, so what we're going to be talking about mainly today is the internet layer. So much like you have kind of international travel or anything, the internet layer is internet networking layer. So it's just the connection of all our different LANs, all our different networks all over the world. So the main protocol we use for this is IPv4 Internet Protocol version 4, which is the standard IP address that you'd be used to seeing from day to day, your 4 different numbers separated by the dots. The main protocols you have are our Internet Protocol version 4. There's also Internet Protocol version 6, but we will not really be looking at that because that is something that hasn't really come in to being involved or being necessary in networking. At a later stage, we possibly may look into it. We have Internet Control Message Protocol. So this is a lot for kind of sending error messages, could not be found, a lot of these type messages, ARP messages, which is sending out, looking for someone who's there, where can I find this IP address? And then Internet Group Management Protocol, which is where we know our broadcast, which we talked about briefly. It's a multicast to kind of avoid having to send out to everyone in your network another protocol for that. So as we said, we're going to be looking at the IPv4 because that is the one that you will be mostly used to. That is kind of, that's where we're going to, the bread and butter for networking is the all IPv4. So that's what we're going to look at today and we're going to delve into.
Yeah, just as Tom said, we're going to focus on IPv4 for now. IPv6 is starting to grow in importance in our industry. It is still fairly sparse in usage, but I do know there are some larger corporations that are starting to use it, and some of the product vendors are starting to support IPv6. But from an understanding point of view, if we can't understand IPv4, IPv6 is significantly more complicated than IPv4 in many cases. There are some cases that are a little easier, but to start reading an IP address in IPv6 is a lot harder. So let's focus on IPv4, and at a later time, as Tom said, maybe we'll come back and do a webinar on IPv6.
Thanks, Wayne. Yep, so our IPv4 address. So as you can see there up in the top right in our little yellow box, we have our IP address 192.68.10.155. So on a standard network or so, we have the /24. We talked about our subnetting there last week, /24. So the first 3 quarters there of that number of that figure are going to be your network address, and the last digit there is going to be your host address or your actual individual device address. So with IP addresses here, when you connect your laptop into a network, how does it get an IP address? You can't just put a static one on because there may be another device with the same IP address, and then the two of you won't be able to use the network. So how does that actually work? When you plug in and connect, your device is going to send out looking for a DHCP server if it is said to capture an IP address dynamically. So you may notice this when you connect your laptop or you connect a device to a network, that you will have the option of statically assigning an IP address or having one dynamically got from our DHCP host. So what a DHCP host is, it will have a pool, and this pool is the range that you have specified to allow it to give out. So you'll say maybe you have 100 addresses you want to give out, and you'll just say I want it to be from 105 to 205. Don't give any outside of this. When an IP address, when a device contacts this DHCP server, it has a list of all the currently being used or currently leased out IP addresses, and it will take some of the IP addresses that are still saved, that are not being used at the moment, and it'll issue that to the device, and then it'll put it in the leased section. It'll mark it as one that it is currently being used, and then it will usually give, maybe depending on settings, 24 hours, and then your device will have to renew its lease. The DHCP lease, next step, is how we go about is what is given out. So when you lease out your IP address, you have it for 24 hours, and then it'll have to be renewed, or else it will be taken back and can be used for another device. Now, as we said, we might have a IP address range from 105 to 205. However, we might have a management controller that's 150. And we obviously don't want something jumping on the network and being issued out a 150 address, because we need to contact the management controller, and we can't have the management controller contacting the DHCP server for an IP address, because if it contacts the DHCP server, you might get a new one every time. So what we do is we put a static IP address on this management controller, and we reserve it. So we take it off the lease, we will take it away from the DHCP pool, and we will make that as one that is not considered one to be leased out. That's how it works, and we have a static IP address assigned on our management controller, so that's going to be stationary. So that's how we can have all of the devices connecting, communicating, being on the same network, but also we're not worried. We have the list of ones that IP address that can be given out, and the list of ones that we want to keep saved for static ones. We also have subnets. So as I said, the first 3/4 of that number we see in front of us, that is usually in a class C /24 address that is usually used to define your network. The last quarter is used to define the host, the device itself. However, in a class C, you'll have 255 addresses. 254 you're able to use. You can have, you might want to be able to have that more or less. So it is the IPv4 address that we would break up, that we put a subnet mask over. It's all with this address that we can use to divide our network up into smaller or larger networks with more hosts, with larger network, with more bits for the network address, more bits for the host address. So that's what we're actually using is the IPv4. This is all using our IPv4 addressing. Then we come down to our gateway. So you're usually in a class C network, or the typical one we'd be dealing with /24, your address is going to be always .1. It's going to be the first number. It's going to be the first number of your gateway. Or sorry, it's going to be the first number of your addresses. So if you have a network, you would generally consider this network here to be the 192.68.10.0 network, your gateway being .1. So that's how people know how to contact. That's how, when your messages are being sent to you, everything else is only going to be using, every other device, everything in the network is going to be using your network address. They're going to be looking to get it back to the .1, get it back to your network, and once it gets inside there, that's when the host address comes, and the gateway will know to send it to you. So it's just how we break them all up, how we use it, what parts are used for the internet, what parts are used for inside your LAN, and just it's all breaking up the IPv4 address. DNS is the final stage. That's when we have you type in www.google.com. Now that is not itself an IP address. So what we need to do is we have to contact a DNS server, a domain name system, taking the name that we have typed in and converting it to an IP address of a server. Sometimes there's one server, sometimes in something like Google or Amazon, we're going to have multiple servers. What we're trying to do is find the nearest one to us that has the quickest communication. So these are all the things, the ways we break up IPv4 and IPv4 addresses.
Yeah, just taking a moment to step back. We talked about MAC addresses a few sessions ago. MAC address is tied to the hardware, so it would be the closest thing to a human DNA. It doesn't change. There are some exceptions there, but in general, MAC address is assigned by the manufacturer, and it's fixed forever until you throw it away into the garbage. An IP address is a name that we give each other, right? I call Tom, tomorrow he could go to the name office and ask to be changed to Bob. right? So that's an IP address. That's the closest thing to it. Again, subnet we talked a lot about. Subnet is a very, very important concept. A subnet is a small network, and within that network, every device can talk to each other without going through any kind of router or gateway. So it'll be like locking a group of people into a room. They can talk, they can communicate to each other freely. And then when you go out the door, that goes through a router in some way. Gateway, or the term default gateway, is very important. We'll come back to that. But gateway is the gateway to the outside world in some way. And then DNS is something like a white page. You can look up where Tom is, and Tom is sitting at desk 17. That'll be the closest thing to DNS.
Perfect. Thank you very much, Shane. Yes, then we have to go into DHCP and how this actually works, and what we were just saying there even briefly as we covered it. So it is client-server protocol, which is you have your client and you have to go to your server and ask, it is a request, can I lease an IP address for a given amount of time? So the device, that laptop, it comes on the network. What it does is configure, well, it will just naturally send out a request. You see here we have the IPv lease request. The DHCP server will then offer an IP address. The IP address you can have a preference. You can have one that you would like. You can set your settings to say, if possible, take this IP address, or maybe you would generally, you might try, if you connect to a network and you have previously got an IP address off it, now and again your laptop will try to renew that one, it won't be allowed. So you can have your lease request, and then you can have your DHCP server can acknowledge as well. So you'll then say to effectively, can I have an IP address? Do you want this one? Yes, that will do. Okay, that is yours. So it's just obviously with all kind of networking and all things, there's a lot of acknowledgements. Is it okay? Request and acknowledgement. So a bit of a back and forth, confirming that the two of them are in agreement. This IP address is now yours to have for the agreed allotted amount of time. You will do, as we had mentioned, you're going to configure this DHCP server with our DHCP pool. That's going to be all the addresses that we want to be allowed to be sent around freely or to be allowed to be leased out. And then we can remove or reserve any static IP addresses that we do not want to have to be sharing, or we don't want duplicates of occurring.
A couple of notes on DHCP servers particularly. One thing is, be careful, DHCP servers are fairly easy to set up. And so sometimes we find in networks there are more than one. That's a big no-no. Gotta be very careful with that. Second thing, Tom mentioned reservation of addresses and static IP addresses. There are different terms, different concepts, but they do tie together. One thing to note about DHCP servers is that they do not check what is out there. So if DHCP server is allowed to give out a range of address, and one of the device in that range, so if one of the address in that range is already used by a statically assigned device, it will not know that. It will not check before it leases out an address. So that's two things to watch out for. Make sure you only have one DHCP server, unless you really know what you're doing. And second is, if you are using static IP addresses and you are combining that DHCP servers, that's okay. But just make sure that the range that you're using, that you're allowing the DHCP server to use, does not overlap, unless you know how to use REST.
Perfect. Thank you very much, Ping. Yep. So just go. Even as Ping was saying there, yeah, the way to view kind of reserved and leased or static, or those there is static is to do with the device itself. Yeah. So there are two, and they're quite the same. But static is to do with the device itself. You're telling the device that's your IP address. That's all you need to know. It's not going to send out a request. It's going to jump on. It's going to be very stubborn in only working with that IP address. If you haven't agreed or talked to your DHCP server beforehand, then it might not realize that you've agreed to use that as a static. It's not going to know to reserve that, to take that out of the pool so that you can have it. So it's kind of almost making an agreement, make sure you have your configuration set up properly. Dynamic and reserved leases. Yep. So once again, just going through it, it is just the leased ones is making sure that you tell your DHCP server, take something off the network. Don't takes that IP out of the pool. So not take it off the network, take this IP address out of the pool so it's not given to another device on the network and causing issues. This is quite a common issue. You'll see if it is not set up correctly, you will often find that anything with the same, there'll be many things such as printers, stationary devices, especially on an OT network, where they're not going to be need to change the IP address. So it's always something to maybe realize there's two kind of ends to putting a static IP. Static IP is fixed is, once again, you almost are turning off your DHCP negotiation. You're telling your device, your controller, printer, even your own laptop, don't bother trying to ask for one. This is the one you have. You're good to go with that. So you can go for the next slide there, Ping, unless you have another.
Notes around static IP addresses in the building automation or the smart building operational technology space. We tend to use static IP addresses. I think when we're looking at 10 years ago, when we had a few tens, maybe a couple hundred devices, that approach was okay. Now we're looking at every VAV, every lighting controller, every device, and we're talking about thousands and thousands. Our recommendations to try to use dynamic and reserved IP addresses. And again, it's a little bit beyond an introductory session now, but we can help you there. So if you are building a new system, try not to use static IP addresses, mostly because in the future, as you grow and your subnet runs out of space, it's all manual work. You have to go to every device and manually change the information, as opposed to if you use a DHCP server, you can change it centrally and everything gets affected from there.
It was with the one view and the way Optigo, whereas Eve setting up their OT networks, it doesn't require you to be aware of, you're not telling anything to an IP address, so it's all from the one GUI, so it doesn't, there's not that difficulty, or that you can have dynamic IP addresses, so if the switch's IPs change, we're still all seeing it from the one GUI with the switch name, host name and stuff, so it's a lot more easy, and doesn't require you to need static IPs.
Yep.
Yep. So for IP routing, you just routes are going to be based on your routing table, so you will have different means. You can have EIGRP, OSPF. There are different ways of routing protocols, different areas, how you send messages across, how you update. These are all different protocols about how it goes through the network, how it goes through the internet. So an example here is we have a device, and our device IP address is 10.10.88.100. And if we were to get that device and we want to send a message to our, well, we say we can have some friend we know, a client whose IP address we know, or possibly someone we don't know, in which case we have to send out, we have to ask for the IP address, we have to get find the best route, if it's not a known one or learned one, to us, and we will send it to our gateway. We'll send it to our gateway, we will send it to the router, we'll send it to 10.10.0.254 then. We will send it through to the next step, which is the other end of the router connecting to a different network. I believe, sorry, if this, you might have 10.10. Or /16, I think it's /24. Okay, so we have our gateway there. So we're working on all /Cs here now. That's perfect. So we have our message coming from our computer, heading out to our gateway, heading out to our gateway address. That's then going to look for which network we're trying to connect to. Once again, we're only dealing with the network section. So we have the, as we go to the next part, 192.168.11.1. You can see that we're only dealing with the network. We're only the first 3 bits. The dot 1 is going to be fairly consistent for /24. Then when we get into the network, we'll realize that we're going to send on to the dot 20, which is the device. So with everything, this is the fairly simple one: device to router, router to device. But when everything in sending messages, there could be multiple routers. You could have 10, you could have 10,000. It's when you're saying going across the internet, there's a million number of ways you could be going through connections, and you have to have these agreements, these just the best way of finding out how to get your message across, even be it RIP or something more old school. If it's the way that it's set up, you have to configure it to have different means. Now, I don't know if we'll go into as depth in the different types of routing protocols, and I don't even know if they're quite as necessary for some of the tasks we'll be doing, but there's just a number of ways that you can take different routes, learn different routes, and negotiate different means of keeping routing tables updated and topologies updated in your network.
Yeah, so if we go back to, on our very first session, we talked about how networking has a lot of similarities with the postal system or parcel shipping. If you think of the 10.10.88, imagine if you were a large office, you're a big corporate 100, and you have thousands of employees, and you're sending letter the person who's picking up the letter, so an internal person picks up the letter and it says, okay, Bob is sending a letter to Sue. Sue is in accounting. I will just directly send it to Sue, deliver it to Sue. That would be a communication within a subnet. Now, Sue knows that if Bob wrote, I want to send it to Tom at a different company, Sue does not need to know that the other company is exactly located somewhere. It just knows that it's going outside of my office, going outside of my subnet. It will automatically go out to the postal system, the US postal system services, or go to FedEx. That will be the equivalent of default gateway. So because it knows it's going outside my network, going outside my office, I will automatically take that parcel, take that letter, and give it to US Postal Services. And then from there, they will see, okay, it's going to Vancouver. I will then route it to this distribution center, then that distribution center, and it will eventually get to Tom. And the distribution centers will be the equivalent of the different routers. And knowing where it goes, that's your route. So the default gateway in this example is that anytime it's going outside of your office, I would take it out and bring it to US Postal Office. If you had a more complicated setup, you could have multiple routes. So it could say, if it's going to Vancouver, I will go through FedEx. If it's going to Idaho, I'm going to go through US Postal System Services. So that's your different routes. One quick note here, bringing back to our industry, building automation system, in BACnet particularly, routers do not pass broadcast packets unless it is a broadcast protocol it understands, such as ARP. And that's a pure reason why we have BBMDs, because routers do not pass broadcast traffic. So a who is and I am a unconfirmed COV, it's a broadcast packet most of the time. The router will block it. And so we're not going to go to BBMDs now, but BBMDs basically just take the broadcast packet and then sends it to another BBMD over a non-broadcast approach, which is a unicast, and then the other side will send it again. Okay.
And then finally, thanks, Ping. We have DNS. So as we mentioned there, DNS is just the way we look up, as the example there, URL www.optico.net, and you're going to look that up, and your computer is going to get back an IP address because it has to actually just contact and get this information of how the GUI looks like, or the information you were trying to get at. That's going to be on a server somewhere. So that is going to be, even when we say the cloud, and it's kind of, obviously the cloud is kind of seen as something up in the sky, or so it's just a data center somewhere. Everything is located as a computer in a room with some air conditioning units, keeping itself cool somewhere. And that's what we're looking up. We're trying to find the nearest one, or the one that we're looking for. So it's the way we can go find what IP address is tied to the URL. Yeah, the yellow pages of internet, I think how Ping puts it, it's very much that's what it is. It's where we find the actual information, the address off of the common, or what we're used to using, the phrase, terminology we'd use for a website. Yep, so we get the IP address from it, and you can central registry hosted by trusted companies, ISP, Google, etc. So it's just how we find these, and there's going to be multiple servers for the big companies. We're often trying to find the closest one as well.
Just a couple of fun facts. There was a virus a few years ago, 2016, I believe, called Mirai. Mirai turned a bunch of security cameras into attack bots that attacked a few of the major DNSs in the world. And what it did is it flooded the DNS with so many requests that the DNS was not able to respond to the real requests what others actually wanted. For example, if you go to www.optico.net, the server was so bogged down by these requests sent by security cameras, it was not able to respond to real requests, and it actually momentarily took down, quote unquote, the internet, a few of the major websites that we all use and love, particularly today.
Yes.
Tom, I suggest we skip the slide. It's a little, I mean, we're running a little bit of time, so we can skip forward. Again, we can help you if you have more questions around IP addressing, in particular how the whole subnet mask works.
Yeah, I think just briefly just look over it again. Here's some of the protocols that we have. So just some of the ones to be aware of. Private networks, loopbacks are very useful in testing your network, making sure that it is able to send and receive some things. we have reserved network, we have reserved IP addresses, we have network source addresses when you're trying to just check. You also you 8.8.8 if you're ever trying to .8 if you're ever trying to test if you can connect to the internet is ones that you go for, and just some of the more notable IP addresses to look at.
Yes. 127.0.0.0 is probably one that's that everyone should kind of learn. It's sometimes a trick to, if you set up a server on a PC and you want to run a client against the same server on the same PC, you can point it to 127.0.0.0 and it makes it look like you're going to a server, but it's actually going to itself. That's called loopback. The second one, the private network, that's important to know. There are a couple of ranges that if you're setting up your own network, you can use, and it's meant for local area network. It's the same thing as, unregistered frequency bands in radio. And then the third last one, the reserve one, just a quick note, this is a multicast range, a broadcast multicast range. Okay. Our next session is tomorrow at 11:30 a.m., 2:30 p.m. Pacific time. We'll be talking about gateways and firewalls, how to now be able to access an internal network, how do we protect an internet network, with cybersecurity being one of the most important topic of our days now, especially in building automation and operational technology. If you have any questions, please type it into your chat box. We are here to help. If you do not have any questions, we hope to see you tomorrow. Thank you very much for your time. Please leave us your comments on the survey. We'd like to know what you like to touch up more on. And after we get through all these introductory sessions, we may take a few topics and dive into it a little bit more.
Perfect.
Well, thank you very much.
Thanks. Thanks,
Thank
everybody.
you. Tomorrow. Bye-bye.
See you guys.